Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of slope of similar right triangles. This is standard 8.4a in the great state of Texas, and we are using item number 18 of the 2019 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got two triangles here. They are similar and they are right triangles. That's going to help us here. And all the coordinates are integers. So good, no decimals, no mixed numbers or fractions. So we need to figure out some statements here about the slope of HK and PK. So HK is right there. PK is right here. It kind of looks like it's, look, you even got these little arrows here. It's the same line. It just extends through both, and you got one triangle on one side, and that since they're right triangles, right, we can label these as the hypotenuse, right? But I don't think we're going to use our Pythagorean theorem here. We're not necessarily looking for that. We're looking about the slope. So when we're looking at the slope, remember our slope is the rise over run. So that's the change in y over the change in x. So if you want to get technical, you look at your y coordinates, you subtract them. You look at your x coordinates and you subtract them. So let's look at HK first. All right, so slope of HK is going to equal these y coordinates. Well, let's go ahead and plot these points here. So h has got an x of -10. And then it's got a y of +10, all right? So if I'm looking at this y2 over x2, right, that's where it gets a little bit confusing. You're going to put the y coordinate, 10. You're going to put the x coordinate, -10. And then you subtract the other y and x. So this one right here is going to be k is, what does that look like? -3, 5. All right, so my y is 5. My x is -3. All right, so minus -3. That happens all the time. All right, so that's going to be 10 minus 5 is 5. 10 minus -3, that's really 10 plus 3. Two negatives cancel each other out. So -10 plus 3 is going to be, so it looks like it's -5/7. All right, so now let's look at PK. We've already got this K. So P, oh, that's got a 0 in there. That's beautiful. That's just 4, 0. All right, so let's do PK. All right, so we're going to do, let's do this K first. So we've got the Y over the X. And then we've got this Y right here over the X, and that's -4. All right. So 5 minus 0 is 5. -3 minus 4 is -7. Take a look. The slope for both is -5/7. If you have a negative in the bottom or the top, it doesn't really matter. We end up pulling it out, making it kind of look like this. But this is the same as having a negative in the bottom or the negative in the numerator. It doesn't really matter. So it's the same slope, which makes perfect sense because it's the exact same line that's just running through both. They just happen to use it for the hypotenuse of two different similar right triangles. So let's look. The slope of HK is less than the slope of PK. No, they're both -5/7 because the ratio of the change is less. No, it just really just asks in a long way you to evaluate whether the slope is the same. Look at less, equal, or greater. The rest of the verbiage looks the same. The slope of HK is equal to the slope of PK, yes. The ratio of change, that's what we just figured out right here, is the same, yep, as this one right here. So that is going to be correct. This H is greater, that's wrong. What does J say? The relationship between the slope of HK and PK cannot be determined because the triangles are congruent. No, it says similar. So our answer here is G.